Hello and Assalamualaikum to Dr. Muhammad Afif and Dr. Roheda binti Mat Akil. This is Engineering Mathematics 4 and the course code is BEE 31602 Section 5 and we are a student from FKEE. So the title for our assignment is Estimating Unemployment Rate of Malaysia. So this is our group members and we are stand of 3 brilliant guys and I am AMIRUL bin ZUHAILI and my matrix number is DE190203. So without further ado, let's go to the first part. So this is the problem statement. The unemployment rates in Malaysia was below 5% for the past few years. It was in good condition that most of Malaysians still have a job. In late 2019, there was a COVID-19 outbreak that affected the economy worldwide. Malaysia becomes one of the countries in Southeast Asia that affect many local companies to force shutdown. This will make a huge difference in unemployment rate of Malaysia because many people will lose job. Therefore, by using the unemployment rates data for the past few years, it will help to estimate the unemployment rate in 2019. So, on the left side, we can see a table which is it is a data collected from year to year, and we can see that the year is from 2012 to 2020, and the unemployment rates is stated there for each year. So, to be more clear, our purpose was to find or to estimate the unemployment rate in 2019. So for next part will be continued by my friend.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AFANDI bin Muhammad KHUSRIN. My matric number is DE190109. In this video, I will explain about the methodology of our project. Okay, as we can see, we have choose the two methods from the chapter 3, which is the Lagrange interpolation method and the Newton divided difference method. Okay, for the Lagrange interpolation method, we use all the formula, which is the linear approximation, quadratic approximation, cubic approximation, and the lastly is the quartic approximation. So this is the general equation for the Lagrange interpolation, and this one is the general equation for the Newton divided difference method. Okay, this is a flowchart for our group. Okay, first of all, we do a manual calculation and the software calculation, which is using a Maple software. So after both of the method get the answer, we can proceed to the next step. If the method doesn't get the answer, we need to repeat it again. So the next step is do a comparison between the manual calculation and the simulation calculation. So if both of the method get the same answer, we can proceed to the next step. And if the both method doesn't get the answer, we need to repeat it from the start. So at the final step, we need to do a analysis and the discussion by using the data obtained. So from this discussion, we can determine the best method that we can use to complete all the problems. So after we determine the best method, we can proceed to the report writing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azim bin Muhammad FAUZI and my matric card number is DE190145. So today I will explain about the manual calculation and also the simulation results for the assignment. So for this assignment, our title is about the estimation of the unemployment rates of Malaysia. So as we know that Lagrange, we use two methods, which is the Lagrange method, Lagrange interpolation, and the second one is the Newton divided difference. So these are two both different methods. So for Lagrange, there are four types of equation, which is the first order, second order, third order, and fourth order. So for the first order, it was called linear approximation. Second order, it was called quadratic approximation. The third order is cubic approximation, and the last one is quartic approximation. So we go first for the linear approximation. For the linear approximation, here is the data. For linear approximation, it uses two samples of data, which is 2018 and 2020, and this is the unemployment rates, which is 3.35 and 3.38. And then we apply the data into the formula. Here is the formula. As you can see, fx equal to p1x equal to l0 f0 plus l1 f1. So we just insert the data from the table and then we can get the answer, which is P1 at year 2019 is equal to 3.365. So this is for the linear approximation. And then for the quadratic approximation, as you can see, this is the difference, which is the data which is the data used. For the linear approximation, we just use 2 samples of data, while the quadratic approximation we use 3. So there are x0, x1, and x2. So here is the year and unemployment rate in percentage. So we just have to use this data and then we plug it into the formula. This is the formula where fx equal to p2x and equal to l0 f0 plus l1 f1 plus l2 f2. Then we will get the answer is equal to 3.35. This is the answer. And then the next one is the cubic approximation. For cubic approximation, it uses four data, which is 2014, 2016, 2018, and 2020. So this is data that it used, which is same with the earlier method, which is we just use the data and then we plug it into the formula and we will get the answer, which is 3.3019. Okay, the last one is the quartic approximation. For the quartic approximation, it uses 5 data, which is 2012, 2014, 16, 18, and 20. We just have to use the data and then we plug it into the formula and we will get the answer, which is 3.2182. I will prove the answer in the mapper after this. Okay, next for the manual calculation for the Newton divided differences method. So this is the Newton divided differences method. So based on the data before, we use all of the data. So here is the table that we use. This is the numbers, and this is the year, and this is the unemployment rate. And here the bold and underline one is the data that we have to find using the formula of the Newton divided differences. So here is one example, which is for F01, which is located here. If we replace the value with the data, we can get the answer is equal to negative 0.08. And then after we have gathered all the data here, we have done all the data, and then we go straight to find the manual calculation for the Newton divided differences, where we just have to use all the data that we have gathered at the table before, and then we just plug it into the final formula. This is the final formula, which is P4x equal to this, and then we plug in the data that we have got in the table, and then we calculate. The answer will be P42019 is equal to 3.215. So for this method also, I will prove it in the simulation later. Okay, next we go to the simulation part, which is the Lagrange and Newton divided differences method using the Maple solution. So in this Maple solution, we have to run the code, which is the formula inside, and we will get the answer directly, very fast. And then so we go straight one by one, which is the first one is Lagrange and the second one is Newton divided. So for the Lagrange interpolation, we can see here that this is the Lagrange interpolation, and this is for group 6. And here is the data for x is stated for the year, which is 2019, 2012, and so on. And then the y is stated for the unemployment rate for Malaysian country. So what we have to do is we have to run the data first. So here is the data that we get based on here. And then as we can see here, this is the Lagrange. So they have 4 approximation, which is linear, quadratic, cubic, and also quartic. So this 4 approximation is the same as the manual calculation before. So what we have to do, we have to prove it. So we have to run. This is the formula. We just have to enter, and we will get the answer is equal to 3.365. So same goes with quadratic, cubic, and also the quartic approximation. This is the 4 answer that we get for the Lagrange interpolation. Okay, next for the Newton divided. Here is the Newton divided. It's the same with the Lagrange, so I will show you in details on how. So this is the Newton divided difference method, and this is the data where x is equal to the year and y is equal to the unemployment rate for Malaysia. So same here we just have to run the data, and so here is the data, and then what we get here, this is the formula in details on how to find the value in the table. So here is the in detail, so f01, f11, f21 and so on. So after we run, we can get the answer here, f01, f11 until f04. So after we have calculate all the value, we have to make it and put it inside a table, which is here, where we can see it. For example, here f04, it was placed here, which is f04. Here is the place. And then what we have to do is to find the final answer, which is P4 2019, and then we just have to grab all the data here and then put it in this formula, plug it in this formula and run. We will get the answer equal to 3.218 to 81250. So as we can see the answer here, we can see that the final answer is the same as the Lagrange, which is here at quartic approximation is equal to 3.218 to 8120. So therefore that these two methods is having a similar answer and similar question with similar question. That's all from me. Thank you.
Hello again. So the last one is the conclusion part. So we can say that we achieved the objectives because as we mentioned earlier, our purpose was to identify the unemployment rate of citizens in Malaysia. And in this result, we successfully determined the unemployment rate of Malaysia in 2019, which is 3.2182%. So the method that we use to obtain the result is by using manual calculation and the simulation. For manual calculation, we use the Lagrange interpolation method and Newton divided difference method. To run the simulation, we use Maple software. So we make a comparison between the manual calculation and also the simulation, and the value is approximately the same. So from that, we are able to prove that Lagrange interpolation method and the Newton divided difference method can solve real life problems. Thus, we can say that maths is not only useful in class but can also work in real life matter. Thank you.